Thanks. Okay. I feel like this is the Andy and Maggie show.
Not normally this chaotic.
We're not normally this chaotic, we promise. Oh, I know what we're doing here. Why is... Can you stop sharing, Andy? And I'm going to
The
share?
computer's not even on.
Right, I know, because... Okay.
Yeah, I was going to say you might be able to kick them off.
Oh, it's sharing from my screen?
Yeah, I got it. I got
My
it.
computer's not even on. I'm rebooting.
I know, that's why it's showing us blank. There we go. All right. This is funny. Okay. Great. You're all still here with us. So welcome to the final session in what we're calling the Climate Change Teach-In that we've been doing for the past 3 days. Some of you were just with me over in the other room that I was in. We were talking about climate change in Maryland. And we thought that since the latest and final synthesis report from the IPCC was issued last week, kind of hot off the presses, that it would be really useful to kind of go over more about what that report is saying, how we can think about interpreting it, and some kind of messages about what it says and what we do from there, and how we talk about what we do from there. And so I'm going to be talking about the IPCC and a bit about its background. I'll give you a kind of overview of our talk. I'm doing this with Dr. Andy Miller, my colleague, and we both teach on topics related to climate change, but from slightly different perspectives. I teach more on the sort of social science and policy side tied to climate change, and Dr. Miller's taught a lot about the natural and physical science evidence of climate change, but we also intersect a lot. So it's been fun pulling this last-minute presentation together to kind of see what we both already talk about in our own classes and think about how we can talk about that more broadly with others. So one question is kind of for in the room and also online in the room, sort of on a scale of 1 to 10, 10 being like, you feel like you know pretty much everything there is to know about the IPCC, but you're kind of curious to hear our hot takes. And 1 being you didn't really know anything, you think it's a confusing acronym and you just wanted to come and learn more. So who's kind of at a 10, who's at a 5, you're just in the middle, you're fuzzy on what the reports say, or you're at a 1 and you really don't know anything. Do you want to put a chat? You're at a 2. I'm seeing room is a 1 or a 2. How are people in the chat going? I can't even see the chat. Why can't I see the chat? Oh, 4. I see a 4.
So,
okay, 7. Bella, you're going to be a star. Great. Okay. So let me bring this back up. Okay, so I'm getting some sense that nobody seems to be a 10. If you put yourself down as a 10 and I didn't call you out, then let me know. But
so is this going to get screwed up if we go to slideshow format for it?
I don't think so. Okay, so I'm going to go to slideshow, and if it screws things up, someone online, just unmute yourselves and let me know, okay? Here we go. So, yep, I'm borrowing from the logo for the IPCC, and I'm just going to tell you what we'll try to cover now. I'm going to talk to you about what the IPCC is anyway, what its function is, and what the process that is followed to issue these reports that you hear about. Andy is going to jump in and talk about the main messaging coming out of what the IPCC has sort of issued in terms of its findings, and these are not digging into the weeds of the hundreds of pages of reports, but more kind of the slide deck that even summarizes the synthesis that's been done. I'm going to talk briefly about what about this report is new, and particularly about the issue of loss and damage. And then Andy, with a little backup from me, is going to talk about sort of the doom and gloom headlines and how we think around what we do with those. And then we'll sort of have a bit of talk to you about what we can do, hopefully at the end, so that we're not all left kind of leaving this room feeling a little worse for wear. Okay? Here we go. So the IPCC This acronym stands for the Intergovernmental Panel on Climate Change. It was created and established in yes, Andy.
I'm linked in here and I'm not, okay, now.
You know what?
Oh,
This
now-
happened to me yesterday. If there's a delay
Okay, I can see
in the
that,
room.
sorry.
Okay.
Go ahead.
Everyone online see my page with IPCC anyways?
Yes, we're good online.
Thank you. Okay. So created in 1988 by the World Meteorological Organization and the UN Environment Program. These are both entities of the United Nations. It is tasked with issuing periodic reports that help to synthesize and summarize climate science so that can be used for making national and global policy or establishing national and global policy targets and plans. So the IPCC doesn't produce any new climate science. Rather, it synthesizes and develops and agrees on messages that come out of that science. And we're talking about at this stage in our scientific form of production that we have worldwide, we're talking about thousands and thousands of studies that the IPCC, those who work and volunteer their time as part of the IPCC report work, they have to synthesize and issue certain statements. So that goes through a process of scientists, more than 1,000 scientists volunteering time to create these reports and summarize the science, summarize the science first, and offer some synthesis statements about the science. And then additional folks that include people from member nations who participate in the IPCC. Now there are 197 member nations that help, and others from other sectors within across the world that help to review those statements and then agree upon consensus statements. Okay? The IPCC is not another hefty acronym, which is the UNFCCC. UNFCCC. The UNFCCC stands for the UN Framework Convention on Climate Change. That was signed in 1992 at the famous Rio Earth Summit, which some of you might have heard about before in sort of environmental history lectures. It was a very important meeting where several different important global policy goals were established, including the Convention on Biological Diversity, which helped to set goals for countries to set aside land and now marine areas for protection and for conserving biodiversity. But the UNFCCC was established in 1992, and what it does is every year it holds a conference of parties, or a COP meeting. And those COP meetings are where you see a lot of the agreements that are developed to establish targets for countries to meet in terms of emissions reductions and other actions on climate change. So some of you will have heard of the Paris Agreement or other things coming out of the UNFCCC meetings like the Kyoto Protocol. These types of agreements have been outputs from the UNFCCC, but they have also been informed by the summarized science and the consensus statements coming out of the IPCC reports. Okay, so it's a relationship. They are different entities, but it is a relationship that has a bit of back and forth. The IPCC issues its assessment reports periodically, as I said, and so what you're seeing down here on the timeline are what we call the assessment reports, or the ARs, 1 through what we're at now, 6. And so these come out every 5, 6, sometimes there's 7 years between them. And that also reflects the process that is required to develop these reports. So the report that will come after this one, AR7, the work on that starts this July, and that report might not come out until 2027. Okay, so what that means is that these reports, the process for them starts years ahead. They are working on science that is published up to that stage of when they start work. And they're also working on models and predictive models that are being run to help simulate what is predicted in terms of climate change that might be also several years old. So that's another thing to keep in mind with the IPCC reports. What's shown on the bottom of the timeline are some of the special reports that are given, that are issued in certain years. And the only reason why I want to bring these up is because often these are requested by the UNFCCC of the IPCC. They're commissioned. And in particular, a really important one that was commissioned more recently was a special report on 1.5 degrees of warming. And that report was commissioned in advance of the Paris Climate Agreement discussions and finalization. And also the findings from that report feed into this current AR6 that we're talking about now. But what came out in terms of AR6, the assessment report last week, is actually the final product of reports that have come out over the past 2 years. So that's also something to keep in mind, and I'll explain that. Okay. The other piece here is just another interesting timeline that actually I've already gone over a bit of, but speaks a bit more to this kind of relationship between the UNFCCC and the IPCC. You can see when the IPCC was first formed. The first report came out in 1990. So this timeline doesn't really show you where all the reports happened that are done by the IPCC. But I did want to note that in 2007, the IPCC team actually won the Nobel Peace Prize for their work. And as one of the very first times that you see the language of the report talk about high confidence that climate change is human-induced and that it is happening. Okay? And so these are sort of the front ends of all the reports that have come out that have been part of what has fed into what was released last week. So as I said, there were several reports issued over the past couple of years since 2021, and they represent the main 3 working groups that issue these reports. So a group that focuses entirely on what's happening in terms of climate change from sort of the physical science behind understanding climate change. What do we know now in terms of what all that science and those models are showing? Then a report and a working group that looks at the impacts that are happening and predicted to happen from that change, the adaptation, and now the degree of vulnerability that people might be experiencing and ecosystems might be experiencing differentially due to that change. And then a separate working group focused just on mitigation, what is being done and what needs to happen in order to meet certain goals in terms of reducing greenhouse gas emissions. The special reports on the right are the ones that were tasked by the UNFCCC, things that we needed to know more about, specifically about what's going on with our ocean and what's going on with the cryosphere, right? How do we understand more about the science in those 2 realms? And then climate change specifically tied to land, and then this 1.5 degree report. Okay, I'm going to hand over. Oh, last thing. Sorry. So there's a lot of time lag between these reports. That's something I want folks to keep in mind if you're learning more about the IPCC and its sequential reporting or periodic reporting. There's also calibrated language. And so this is something that was adopted by the IPCC as part of its method for communicating findings. So anytime you start to dig through one of these reports, even the synthesis report that kind of gives what we call the famous summary for policymakers, that's supposed to be its most condensed version and messaging. And I think this one is like 60 to 80 pages. So that summary for policymakers will give you different boxes with sort of, okay, this is the finding, this is what is happening, and it will talk about a degree of confidence and a degree of likelihood. So the confidence is based on the confidence in what the science is saying about that particular finding, okay? And then the likelihood is more based on what is predicted, right? What is the sort of certainty about a finding or what has been modeled as a prediction? Okay, so those are important things to think about. And these are some of the examples. This is actually the specific example of what that confidence terminology and that likelihood terminology conveys. So when you see a finding and a message in the IPCC report that says very likely to happen, that's 90% probability or more. Okay? And also, then you can say the same thing looking in terms of confidence. You can understand more about what those chances, what those probabilities are. Ultimately, what I think is useful to keep in mind is because of all the iterations, all the people and who are looking through all this science and reviewing it and coming up with these statements and agreeing on them as consensus statements, this kind of results in a more conservative, in terms of little c, statement about what is happening. Okay. The most important thing, we put in a lot of slides because we have so much to say. Okay, the last thing I get to say before I hand off to Andy. I think one example I wanted to bring up is that because you use this calibrated language, even though it ends up sounding really qualified, like very conservative little c, it does give you an idea of how these statements are changing from report to report over time. So the AR6, our most current one, and the summary for policymakers is saying human activities have unequivocally caused global warming, with global surface temperature reaching 1.1 degrees Celsius above pre-industrial levels in the 2011 to 2020 decade. And that is high confidence, okay? 2001 and 2007, we're talking about human-induced climate change being a likely finding, and in 2001 and shifting to in 2007 to very likely or a high probability. But we didn't reach this point of confidence in the statement, high confidence in the statement, and it being human activities unequivocally causing global warming until this report. Okay. Do you want to talk about this part? I need to stop talking.
All right. So I snuck this one. So
yeah.
Hi, everybody. I'm Andy Miller, and I'll say, having spent 10 years involved with the Chesapeake Bay program, I've learned that every big environmental management effort involves an alphabet soup of acronyms that take a long time to learn. And as you've probably gotten the inkling from Maggie's very nice explanation up till this point, these IPCC reports are not easy to read. You cannot open one of them and read all the way through. I can't do it, and I have more background than most of the students here. So this is an attempt to turn this into something that makes it easier to follow what actually is going on, and then we can talk about what it means. So this is just an extension from the slides that came out with the synthesis report that apply with color codes the kinds of confidence levels that you heard Maggie just talk about. And see, does this cursor work? So one thing I want to point out is that they have now added a category in black called fact. They have never before been willing to say, absolutely, this is 100%, it's a fact. You almost never hear that, right? So if you look at the screen, this is just to point out that if you look, there's two of these slides. I'm not going to read everything on them. But there's a bunch of topics under atmosphere and water cycle changes over time and under ocean changes over time. And even these red colors are very likely. These sort of little bit darker colors are extremely likely. The colors that are sort of very dark brown are virtually certain, and the black ones are fact. So that kind of gives you the indication that both for these categories, both for the observed change assessment and for the human contribution assessment, they have really ramped up considerably, as in, why is this not moving? Okay, as in, some of these are still in the very likely or extremely likely range, but by and large, and warming of the global climate system since pre-industrial times, that's in the virtually certain category, so is the human contribution assessment. Okay, so, and actually, these aren't black on the screen. They're just showing up a different color in the projector. So this mirrors my personal history as a professor here. I started teaching here in 1983, and I downloaded this cartoon in well, when it came out in 1990. And it shows this guy who, over a period of 30 years, gets older and grayer and more grizzled. And he starts out saying, this climate change thing could be a problem. And when I started teaching, it was like, we think this might be an issue. We don't really know yet. And I was very careful to say that. So by 1995, he's saying, definitely a problem. 2001, we really should be sorting this out pretty soon. By 2007, I'm sorry to sound like a broken record, 2013, and that's when this cartoon was published, 2013. We really have checked and we're not making this thing up. And in fact, all the things you know about in terms of the opposition to this and the mythology that was spread, a lot of it by people who stood to make a lot of money if it was not accepted. And then 2019, is this thing on? So here we are in 2023, and this is the story of my career teaching at the 100 level about climate change, because now I say to students, guess what? It's real. You're going to be dealing with this for the rest of your life. So will your grandchildren. This is not to say the world is coming to an end and you shouldn't have children, but it means, well, there's more about this in another slide, so I'll leave it at that. So I'm just going to show you some slides. It's a mixture of some content and some of the sort of takeaway messages from the slide deck that was produced by the IPCC. This is not from the IPCC. And it's just an indication, because people argued whether both the measurements and even the models were reliable, and said, well, the scientists can't even agree on whether their measurements make sense. This shows you when you superimpose from multiple different sources, they're extremely close. So this notion that there's disagreement among the scientists is nonsense. You see on the right side, it says the scientific consensus. I mean, there's a few scientists who disagree, but
I was going to say, even ExxonMobil's own scientists had remarkably accurate predictions.
right, they just weren't allowed to say it in public. Yeah. So you see on the right here, scientific consensus now at 99.9%, 88,000 plus studies. So this is no longer in any way, shape, or form controversial. So now I'm just going to go through the slide deck that was produced to go along with the assessment of this report, which came out just a week and a half ago. And I'm going to go through these pretty quickly. These are big picture, sort of, high altitude look at things. And then we'll get into a few specific details. So this one basically gives you all the different sectors on the right side: water scarcity and food production, health and well-being, cities, settlements and infrastructure, ecosystem structure, species range shifts and changes in timing. The big message is adverse impacts from human-caused change will intensify. To most of us, this is not a surprise at this point. Extremes become more widespread and pronounced with every increment of warming. And you'll notice that the extremes are greater, particularly in the northern hemisphere, the closer you get to the poles, but they're extreme everywhere. I'm sorry? Yes, right. I apologize. Correct. You look at they're more extreme on land than in water, although there are big changes happening in the ocean. And actually, some of them are looking like some of the exchanges that have caused major geologic extinctions. So the hope, right? Mainstreaming effective and equitable climate action now will reduce losses and damages for nature and people. I'm trying to move this thing. Climate action provides co-benefits, and multiple feasible and effective options are available to reduce greenhouse gas emissions and adapt to human-caused climate change. The challenge, cut emissions quickly, sharply, create a safer, sustainable world, scale up practices and infrastructure to enhance resilience, cut global greenhouse gas emissions by nearly half by 2030. That's 7 years, folks, okay? And one of the questions we have to ask ourselves is, okay, are we going to do that in 7 years? And if we don't, is that the end? So we're all shaking our heads in here, right? We don't believe that's the end, but that's what they're saying you need to do in order to reduce the impacts to stay close to 1.5 degrees Celsius. Action required along numerous dimensions. So the path forward is clear. Tried and tested options are available now. They need to be designed for diverse contexts. They need to be scaled up and applied widely. See, these are pretty easy to understand compared to just trying to read the reports. Fairness is one of the solutions, right? So those who contributed the most to climate change are often the least to climate change, are often the most vulnerable. Millions are exposed to acute food insecurity and reduced water security. Biggest impacts are in Africa, Asia, or parts of Africa, Asia, Central and South America, less developed countries, small islands, and the Arctic. And people in highly vulnerable areas are up to 15 times more likely to die in floods, droughts, storms, compared to those in the most resilient areas. So equity and justice is a big piece of this. Increased financing for climate action, 3 to 6 times the current climate investment. There is enough global financing to rapidly reduce emissions. Developing countries are going to require external funding to meet adaptation needs, and options are available to scale up financing. Whoops, I went backwards. The way forward, climate resilient development, integrating measures to adapt to climate change with actions to reduce emissions in ways that provide wider benefits, improving people's health and livelihoods, reducing poverty and hunger, clean energy, water, and air. Okay, so, and then they talk about enablers for effective climate action, political commitment, inclusive governance, international cooperation, effective ecosystem stewardship, sharing of diverse knowledge. Human factors also enable action, trust, collaboration, recognition, sharing of benefits and burdens. I think we all understand what these things mean. The question is doing it on a global scale in practice, right? And their final slide in this deck is that our choices will reverberate for hundreds and even thousands of years. So that's a big responsibility on all of us. So now I'm going to show you some of the things that come out of other parts of the assessment report. And these are just 4 indicators here. So I'm just going to point out on the left, you see carbon dioxide concentration in the atmosphere. You may not be aware of this. Current concentration of carbon dioxide in the atmosphere is about 419 parts per million. Pre-industrial, it was about 280. It was never during the Pleistocene higher than about 300 at most, and usually lower. So it's higher now than it's been in 2 million years. Sea level rise, the fastest rates in at least 3,000 years. And given the rate of acceleration, I think that'll probably turn out to be an underestimate. Arctic sea ice area, lowest level in at least 1,000 years. Glaciers in retreat is unprecedented in at least 2,000 years. Those who've heard Christopher Schumann's presentation on Greenland glaciers on Tuesday will have seen some visible examples of what's going on there. And then these are some of the kind of factors with illustrations with pictures. Extreme heat, more frequent and more intense. Heavy rainfall, more frequent and more intense. We're actually doing some research on increasing probabilities of extreme rainfall here in Baltimore, and we can talk about that at another time. Drought increasing in some regions. Fire weather more frequent. If you've looked at what's gone on in the Pacific Northwest and in California and Australia and other places around the globe, even in Europe, this has been a huge issue. Ocean is warming, acidifying, and losing oxygen. As water gets warmer, the solubility of dissolved oxygen goes down. The issues with limited dissolved oxygen on ecosystems are critical. Future emissions cause future additional warming. So this shows you, for a range of CO2 emissions, the very lowest actually starts to level off at a little more than 1.5 degrees Celsius. And that the idea there is that you might overshoot and then try to come back down again. And there's actually stuff about that in the reports. But the very high CO2 emissions take you up close to 5 degrees Celsius. That is truly catastrophic. There are likelihood scenarios, but this is not the likelihood scenarios. These are just what happens if you have those levels of emissions. And then these are the 5 scenarios that are used by the IPCC. They are updates from the last 5th assessment where they were using RCPs. I can't remember what that stands for. But these basically talk about different levels of greenhouse gas emissions, what the consequences might be in terms of estimated warming at different points in time. And you see the very low is getting you in the range where you hopefully stay closer to 1.5 degrees Celsius and maybe eventually come back down again. But the very highest ones, so they've attached likelihood to each of these, right? So likely is the one in the middle, SSP 2-4.5, which gets us to maybe around 2, possibly going up to 2.7. The range could be as high as 3.5. That's the likely scenario in the near term. The question is, can we, even if we're on that, if we get to that point now, can we evolve to the point where we get to the very low? And that becomes a question of a lot of different things that have to be done. So this just points out that it says every ton of CO2 emissions adds to global warming, and on the x-axis is the cumulative CO2 emissions since 1850. On the left, on the vertical axis, is temperature change. So what you see here is that the more you continue, depending on which scenario you're on, you get to higher temperatures, and this shows it to you in increments. And it's pretty much a linear rate of increase. As you add that much more, you get that much more temperature increase. This is an interesting simulation of, if you look at only natural factors as opposed to human-induced factors, you get the gray area on the bottom, which kind of tools along close to 0 degrees change based on solar change, volcanic processes, and so forth. The observed is the, let's see, which one's?
Is the black line.
The black line is the observed, is that red?
Brown.
Brown. I have a little bit of color blindness. The brown is the simulation. So the simulations do a very good job when you include what humans have done in reproducing what we've actually observed, right? So the models may not be perfect and there's some uncertainty, but they do a good job of telling us. And that's why we think there's pretty high confidence in terms of what we might expect. This is just a little thing I included because it shows here in the upper right there, over the last 50 years, global temperature has increased at a rate unprecedented in at least the last 2,000 years. You're looking at the last 10,000 years on this axis here, and what you're seeing is that the temperature has not been this high since before. That's basically since the Holocene began, but this last decade has been warmer than any multi-century period since 125,000 years ago. So things are changing really fast, and I should say much faster than when I started teaching. Nobody anticipated things could ever change this fast. So there's been a lot of surprises. This shows you other changes. Global surface change relative to 1850 to 1900. Again, shows you, depending on which scenario, how much temperature change you get. And the 5 scenarios are just shown there on the right in terms of what names they give them. September Arctic sea ice area shows you that has been sinking, practically ice-free. Seems pretty likely that we're going to get there. And it will take a long time to rebuild Arctic sea ice if we do get there. And this shows you global ocean surface pH. A lot of people don't know about this, but as you add more carbon dioxide to the atmosphere, it combines with water. That creates carbonic acid. Carbonic acid mostly goes into solution in the ocean, releases hydrogen ions. The ocean is naturally very well buffered, slightly alkaline system. And this was the biggest shock to me in terms of climate change, I think, of almost anything I saw when I realized that the ocean's pH is now changing. The global ocean is a huge amount of water, and for the pH of the ocean to change means if you've ever done a titration experiment in a high school or college chemistry class where you're adding droplets of acid and you titrate and then you reach a point where all of a sudden you've exceeded the buffering capacity and the pH can shift rapidly, that's what we're doing, a giant titration experiment. And it's getting to the point where, depending on which scenario we follow, we're looking at possible loss of ability of many organisms that secrete calcium carbonate and other carbonate shells to actually build their shells. So that's a very, very serious issue for global ecosystems. Global mean sea level change relative to 1900. This shows you the 5 scenarios. There's a very nice report on sea level rise in Maryland that came out 5 years ago. It included some scenarios that had sea level rise going up as high as like 7 meters in the span of a couple of centuries. Those are now considered very unlikely, but it's highly likely that sea level will go up to maybe by 2 to 3 feet by the end of this century. And the thing about sea level rise is that it's caused by the loss of global ice. Even if we have low emission scenarios, the temperature is not going to allow the glaciers to regrow. So we've already bought a certain amount of sea level rise, and some of that truly is irreversible. The thing we have to concern ourselves with is how much more are we going to get? So you have to actually do something well in advance of when you expect it. The thing on the right shows you scenarios for 2300 relative to 1900. So the SSP 2.6, which is just below the middle of the road option, you could see as much as 3 meters of sea level rise by 2300. We won't be around to see that, but hopefully our great-great-grandchildren will. And if you go on the higher trajectory, then you could be talking about really high rates. The Antarctic glaciers, we don't fully understand enough to be able to say exactly how stable or unstable they're going to be. There's some worrying signs. So sea level rise has local effects, right? This is just to show you a coastal flooding event from storm-induced extreme high tides in downtown Baltimore, but the same thing has happened regularly in Annapolis. This is from October of 2021. This was not caused by climate change, but rising sea level means events like this become more likely over time. People in Norfolk are experiencing this on a regular basis, so are people in Annapolis, right? Fair weather flooding. Sunny day flooding, right. This just shows you if sea level were to go up 6 feet, what would happen here in Maryland? And if you'll notice, if you look at the lower eastern shore, basically more than half of Dorchester County is gone. Large parts of Wycomico and Somerset are gone. A lot of other areas have problems as well, but these are the most dramatic because there's large areas on the lower eastern shore that are very low elevations above sea level. So that's not going to happen by 2100. But as you just saw, some of the scenarios could have it being higher than that by 2300. And just lastly, for this report, which just came out from the Chesapeake Bay Scientific and Technical Advisory Committee, is a report on rising land and terrestrial and bay water temperatures, ecological implications, and management responses. I've got a link over there on the left. If anybody's interested in getting it, you can download that report now. But this is a big issue because water temperature might be the single biggest, apart from sea level rise, sea level rise and water temperature are the two biggest impacts on the bay. And those changes are really big. Okay, Maggie.
Okay, so I want to say that the scenario, the worst of the models, right? The SP 8.5, 8.5. Thank you. Is highly unlikely, right? That's what that clearly states in that thing. Remember how I said that the IPCC reports are based on older information, and the models that are established and designed to run these predictions and predicted scenarios are these ones, the the acronyms are beating me. The S models were, as I understand, were first published in 2011, and a lot of these were run for this report in the sort of early 2010s, right? So 2012 to 2014, that's when these scenarios were run. And from what I have been learning, a lot of what actually has already happened in terms of transition with, solar becoming more affordable and whatnot have helped to make that modeled scenario less likely, okay, over time. So it's a bit useful to if you're looking for some flickers of hope in these fairly dramatic predictions, that one is one that is sort of 90% unlikely, right? That said, what people are also doing with that particular model is terming it the fossil fuel development model or the business as usual model. And actually what the IPCC report states is it requires a threefold increase in fossil fuel use, a tripling of what we're doing now, nor are we on that particular pathway at the moment. There's reason for concern with the ramp up in fossil fuel development in the past couple of years with the Russia-Ukraine war, but and the push by the U.S. to, as we say, dig to the bottom and on fossil fuels. But from what a lot of climate scientists are saying, that scenario is less and less likely. Okay, so that's perhaps useful. This we also found to be a useful image that is actually was also included in a piece by the Carbon Brief. So if you go to carbonbrief.org, they have a really great lengthy but useful synthesis and question and answer document on the IPCC AR6. And so this is sort of also giving you an idea of what future scenarios mean in terms of what we would experience if we were born in different time periods, living now and into the future, aging into those time frames moving forward. And so we can share this slide deck and you can visit some of those resources and sort of think through this piece as well. Okay, so I think importantly, the other issue that comes to mind that Americans don't think of as much, a lot of Americans do believe that climate change is happening, and majority of Americans do believe that it is human-induced at this stage, according to polling data. But we are less likely to think that it's going to affect us or that it's affecting us now, right? We do think that it affects other people, and it certainly is affecting a lot of folks now and a lot of people in other nations. And so I wanted to point out a couple of images that maybe you've seen before. This is actually an image from the former president of the Maldives in 2009, famously holding a cabinet meeting underwater to sort of raise awareness about sea level rise and how that's impacting small island nations in the ocean. This is kind of an alliance that is developed between small island nations who feel like they don't have much of a voice at the UNFCCC level. And so they've developed a coalition, just as tropical forest nations have developed a coalition. And they pull together to have a larger voice in pushing for policy change at those levels. If we follow a scenario and a path line that is currently very likely and that would represent an upward range of over 2 degrees warming, these nations are gone, essentially. Coral reefs, gone. So those are parts of the things that we will face losing as we sort of follow the current trajectory, and if we aren't acting to keep things below 2 degrees warming, and well below, as we would say. So lots of nations have come forward with different sort of pleas. This one is, well over a decade ago. We're also talking about what does that mean when these small island nations sort of are swallowed up by the sea, and others in mainly in nations in the global south are pushed to flee their homes because of uninhabitable conditions or extreme events that are impacting their lives. And we're already seeing, because it's already been recognized as a thing, we're seeing climate refugees as a category of people, of refugees, and we're going to see more and more of that moving forward. This was fast forward to just a couple years ago for the COP that took place in Glasgow in Scotland. The president of Tuvalu did not attend the COP due to COVID restrictions and concerns, but did sort of make a speech from within the water and in the ocean in order to sort of convey a message about sea level rise impacting his small nation. Interestingly, I just heard this past fall on NPR a story about the nation of Tuvalu establishing a presence on the metaverse, in order to try to preserve cultural knowledge and establish a national presence in the metaverse, including issuing records for people and including government services for their citizens, because the country will no longer exist on land. And so that is something that we're seeing happen a bit more. This is the first signal of that, but a couple of other countries have started to establish a presence in the metaverse. Seeing that story gave me pause. So that brings us to what is really new in this IPCC report that is specifically going to tie and continue to tie to conversations at the UNFCCC meetings at the next COP, okay? This happened at the past COP. These small island nations and a lot of others who are experiencing internally displaced populations due to climate, having more climate refugees and impacts from storms, and from drought and from other changes due to climate change, they are seeking loss and damage recognition. This is no longer a conversation about policy and northern countries, primarily industrialized countries who have benefited from greenhouse gas emissions, feeding money into climate adaptation. The adaptation game hasn't worked for these folks, right? And those monies have not reached those nations. The funds that were pledged and the fund that was established, the Green Climate Fund, was never built up to what it was supposed to be in terms of volume of money. And so these countries are saying, look, it's not that we need money to adapt. We are kind of adapting and we're being forced to move places. We need money and recognition and reparations for loss and damage. And the very language of loss and damage is highly politicized. This is really big that the IPCC AR6 has a mention of loss and damage in here. It's only once, and then it goes on to talk about losses and damages that occur and are likely to occur, but it does have the language loss and damage. And so I would just encourage you, if you're curious on sort of the policy dialogue and the negotiations that are going on to pay attention to when you hear about reports tied to loss and damage. Okay. Doom and gloom.
Oh, okay.
We have 10 minutes.
So I just want to mention there was an announcement of a court case that Vanuatu.
Yes.
I don't know if they won it, but it sounds like they are suing for damages, and they are being allowed to sue for damage on the international courts. So anyway, one of the things we've talked about is that when you look at the headlines that came out in response to this report, they are not necessarily the most helpful, because here's one from The Guardian. Scientists deliver final warning on climate crisis. Act now or it's too late. And they talk about catastrophe, irreversible. So what's people's natural reaction when they hear that? It's to throw up their hands and say, well, there's nothing I can do, so party on. I don't know. Or just go in a hole and hide, right? So, but not all headlines are like this, but here's a couple more, right? This is the New York Times on the left. Climate change is speeding toward catastrophe. The next decade is crucial. And actually, a different article that happened 2 weeks later talks about this in more reasonable language. I'm not going to read the whole thing to you, but it does a fair job of summarizing. Then this one from the Washington Post at the top there. World is on the brink of catastrophic warming. A dangerous climate threshold is near, but it does not mean we are doomed if swift action is taken. So people have different reactions to headlines like this, but then there are other perspectives. This is from the UN, which maybe doesn't surprise you. The UN would tend to want to take an optimistic view. So their headline is, a livable future for all is possible if we take urgent climate action, flagship UN report. There's actually a little video. We'll release the slide set so you can click on the video, 45-second video that kind of says 5 bullet points. So one of the things that we're interested in thinking about, and I'm going to turn it back over to Maggie, is how do we react to this, and what does it mean for how we all respond? Because the fact of the matter is, we all are going to be living with this, and we need to think about how we're going to respond.
Right, and when I talk, or when I listen and read about more of these forms of the media messaging on predicted changes that might happen and how that'll impact people, you hear of a big growth in doomism, and in a way that is as unproductive as denialism. Right, so we've actually seen a decrease in denialism, although still a very vocal sort of sector of denialism and small population of denialists in this country, for instance. A lot of climate folks who are working on climate change communication, who are climate scientists trying to sort of figure out best messaging, and who are borrowing from understandings of behavioral science, right? And what causes behavior change and people to sort of, and what causes sort of our changes in perceptions, are sort of saying, let's just leave the denialism aside, and it's no longer worth spending any effort on it. Similarly, doomism is actually now becoming more of a vocal group, a vocal population out there, and it's taking up a lot of space, and it's causing people to feel depressed, to want to go insular, and to want to sort of not believe in the ability for social change to take place. And this is concerning, and it is something that if you wanted to feel, action actually begets hope. and we'll talk about this a little bit more. And so one of the things to sort of think about and have your radar out for is sort of doomist language and doomism in terms of messaging that you might see, and how that could be communicated differently so as to help mobilize action. Because as this report also clearly says, and as past reports have said, we have solutions now. We have things we can change now. We don't need to design new ones. We actually have things we can do now, and we know what to do. We just actually have to get them done. And we have to get the people who can help make those happen, have them done. I bring up these couple of graphs. I mentioned them in the last class, but about the Climate Change in the American Mind project that is run out of Yale Center for Climate Change Communication in partnership with George Mason University. And they've kind of separated Americans in particular out into 6 groups, from anyone from dismissive, where you would kind of call the denialist sect, out into alarmed, which would include folks who are kind of reaching over into a doomism sort of perspective. Alarmed, though, can also still be a point at which you are, you're here listening to us talk about this because you feel like you want to do some things, right? You want to make some change happen in your lifetime. And so it's just interesting to see how some of those have changed over 10 years that they've been tracking this polling of Americans every year. We've seen that 1 in 4 Americans is now at the sort of state of being alarmed, and this is a doubling from when they first started to track this. The doubtful and dismissive have kind of stayed the same. And so it's just sort of an area that is not moved a lot. And of course, this maps out in this country very much according to political party. But even thinking about how that's changed over the course of time in terms of people believing that global warming is already harming or will harm the United States, you see that change kind of start to evolve from 2008 up until 2020 in this graph, right, to include some more representation of over half of American adults in this particular area. I find some comfort in looking at these types of polling data and more of the questions that they ask to see that people's perspectives are changing. Americans still do not see that direct relationship of climate change in their lives, but they do know that it's happening and they do understand the majority that it is human-induced. It's just more of a question of flipping over into prioritizing it for action and voting on it, right? I vote on climate change now, and I say that to other people, and I communicate that, but we don't talk about climate change. And so that's one of the pieces that is even a simple kind of shift that we all can make. The other thing is that young people are uniquely different in the US, and that gives me hope because I've got some young people in my house, and I work with young people, and I am no longer one of the young people. But where a lot of the change is happening, and this is across the political spectrum, right? Young Republicans are also changing to think that global warming is an issue that they need to deal with and that is human-induced. That is happening in the States. And this is also giving some hope and some motivation to some older activists. You can see now that there's some sort of joining of older and the youngest generations that are mobilized to act, even though in this graph, as you'll see, it's the older generations that are less overall convinced that this is a priority. We're going to get to an end here, and maybe we can have 5 to 10 minutes after. I'm happy to stay. I see a lot of communication now, too, in the climate change communication, science communication space about talking about the word hope. Like, do you feel hope, right? What makes you hopeful? And a lot of people are really kind of digging into that word and what does that mean? And what are the different kinds of hope that we talk about? A lot of people might talk about something that researchers have been terming false hope, right? A hope where, I hope that this happens in the future, where you kind of place the action that might need to happen to make that change on someone else or on something else happening, rather than you actually acting to make it happen. And other people talk about constructive hope, that you gain hope, that you see the possibility of change as you are starting to make it happen. I heard a great quote from Margaret Atwood's book, The Year of the Flood. We must be a beacon of hope. This is from within that book. Because if you tell people there's nothing they can do, then they will do worse than nothing, right? So that's one of the risks of the doomism that you might see out there, is that it makes people kind of, as Andy said, throw up their hands and be like, well, I'm just going to buy my survival kit and go to my bunker under the ground, and good luck to the rest of you, or I'll build my nice biosphere, and there we go. We'll just survive. I also think that Greta Thunberg, there's so many other youth climate activists that I'm not mentioning. I know most of us go to her, and she has played an important role. But she also said this important point, that you can't just sit around waiting for hope to come. Then you're acting like spoiled, irresponsible children. You don't seem to understand that hope is something that you have to earn. And I was going to bring up one final quote that I forwarded to myself last night. That was, oh, and I have no reception. Hold on. I can stop sharing and read it from here. Okay. I'm reading this from Diego Arqueda Ortiz. He's a Costa Rican who wrote a BBC piece in 2020 with the title, "Is It Wrong to Be Hopeful About Climate Change?" And he says, "No individual will bend the emissions curve alone. No writer, modeling team, no forest firefighter, no environmental lawyer will carry the day. But if you're looking for hope, there might be a space in constructing something together, in responsive hope. No single coral restoration program will heal the wounds inflicted on reefs around the world, but perhaps networks offer a way forward. That collective goal and the space of uncertainty in that perhaps is our hope." Okay. I'm going to stop.
So you have one last slide. Are we out of time?
Oh, I do. I stopped sharing though.
Well,
No, I don't. That's it.
Oh, it is. Okay, there was another slide. So
Oh, yeah, no.
so I'm gonna give one quote that I thought about putting in and I didn't. So I'm just gonna, because this one's much shorter and easier.
Okay.
It's from an ancient Jewish text, and it goes like this: "You're not obligated to complete the task, but neither are you free to desist from it." Right? So you don't have to do the whole thing,
Yeah.
but you don't have the right to not do it at all.
Hey,
And everybody has something they can do. So I'll leave you with that.
that's good. Nice. Any we're done. No. Any that was the Andy and Maggie show. We even stayed to time. He and I did.
That's impressive. Well, considering that we started like 6 minutes late.
I know. So we're willing to field any comments or questions.
And we will save this and post it, and I'll bet
Oh, yeah.
we could post it on the CSSS
CS3? Mm-hmm.
CS3
YouTube channel. Yeah, we'll get that on there.
Who wants
I'm going
it.
to stop right